we're going to do a real quick run through of the surface area notes. So the idea is maybe this will be a helpful resource, just a quick run through of the basic concepts to a problem or two, talk about how to set up some of the problems, and maybe a real quick one of those will be a good refresher and help you when you try to do, say, group work during class. So we're just going to see how this goes. This is an experiment, but let's go ahead and go for it. So we're going to be talking about surface area. What is surface area? So it's just the combined total area of all the faces of your object. Basically, how much space is around the object, kind of like how perimeter was what's the distance around the object. Surface area is how much area is around it. And no matter what 3D object you have, you just find the area of all the shapes that make it up and you add it together. That's exposed. But we can simplify this a lot for objects of particular importance like prisms, cylinders, pyramids, cones. Spheres are just their own special thing. There's not much we can talk about. But for everything else we can talk about bases, which would be the base of the pyramid, cone, cylinder, prism, and the lateral surface area. So remember that the lateral faces are the faces that aren't the base. So the lateral surface area is the area that is not the area of the base. Those two things coincide. So for anything that's not a sphere, or anything that's one of these four basic shapes, surface area is base area plus lateral surface area. Before we start talking too much in depth about that, we need to talk about this new word, slant height. So what is that? Let me go ahead and draw a pyramid. Say it looks like this. And then kind of bows out. You can't see those lines back there. So we're used to thinking about the normal height, which is just the shortest line from the apex of the pyramid down to the base. But there's another idea that we need to think about with surface area, which is pretty much the height of those lateral faces. And when we're dealing with right objects, the ones where the apex is exactly above the middle, it's going to be the same on every single side. So this is called the slant height. It's kind of like if you were to actually have to run up the pyramid, that's what you would go. Or it's the height of the lateral faces. You can think of it that way. One thing that a lot of students can get confused about is the slant height is different from the height. The slant height's always going to be bigger, and that's actually by Pythagorean theorem. But just try to keep that in mind when you're doing calculations. You're looking for the slant height for surface area, not necessarily the height. So don't get confused. Alright, so let's start with right prisms, but I'm immediately going to write a formula that is not immediately obvious, and I'll go and try to explain it. So for a right prism, again, this prism could have any polygon as a base, we don't know. So we're just going to call the base area B and nothing else. But because it's a prism, it has two bases. So because it has two bases, we put in 2B. One for the bottom base, one for the top. When we add everything together, we're going to end up with two of them. For lateral area, this might look weird, but it's going to be the perimeter and then multiplied by the height. At first that might seem confusing. Why do we need perimeter when we're talking about problems involving areas? So let's go ahead and draw a prism. We'll go with a triangular prism. And there's no way to draw it so you can see all three sides at once, so we're just going to have to kind of work it out. So it has height h, And let's make these two, or these sides, S1, S2, and S3. If we want to find the lateral surface area, so now we're not dealing with the base, but we have to deal with all three sides. So let's go ahead and start with finding this back area here. So the area of that back place in the green, the back face, would be S3 times height, because it's a rectangle with base S3, height H. Now let's move on and do the front part in red. That's going to be S2 times H. Sorry, that was S1. S1 times H. And then in blue, we get S2 times H. But what's the trick? I can factor out an H and switch my addition around so that this is H plus S2 plus S3 plus S1, but in the right order. But what is this here? This is the perimeter. And it works the same way for any prism. Is you're going to take all the side lengths, multiply it by the height, add them together. So that's why it's perimeter. I could equivalently say S1 plus dot 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 plus Sn, where n is how many sides the n gun has, times h. Those are both the same. So final formula is 2b plus ph. Cylinders are very, very similar, but now we know the area of the base, say radius r. Radius of r, then this is 2 pi r squared. Because the area, the base is always a circle, that always has area pi r squared, so that would be the base area. The lateral area is the circumference times the height, kind of like it was here. So c times h, but we know what the circumference of a circle is in terms of its radius. That's 2 pi r h. So if we add these two things together, we get 2 pi r squared plus 2 pi r h. You can factor out 2 pi r and get r plus h. So that's the easiest formula to plug in if you know everything. If you figure it out piece by piece, you get the thing above it. Pyramids are similar, but the most important thing to keep in mind, two important things really. One, they only have one base, so just B, not 2B. Hamlet would be very interested in this lecture, I think. So now let's draw our triangular pyramid, say. Like that. And now it's going to be the same thing, area of the base back there. And we're going to have perimeter times, not the height anymore, because now we're dealing with slant height. We have to walk up the side of the pyramid instead of going straight up. So now we have to deal with like L, because we have to walk from here to the base. So that's going to be pi times L. But is that it? No. A triangle is 1/2 base times height. So I'm going to be saying 1/2 times side 1 times the slant height plus 1/2 times side 2 plus the slant height. And now all of my things are going to have a 1/2 in front of them. So there's going to be a 1/2 there as well, just because you're adding 1/2 base times slant height every single time. So for a pyramid, it's B plus 1/2 PL. It looks a lot like the right prism stuff, just divided by 2. And that's kind of how you can think about it. For a right circular cone, what changes? So let's go ahead and draw the cone. Again, I should not draw the whole base the first time, but that's fine. So here's what our cone looks like. And cones are kind of nice because this is the slant height. If you tried to walk up this thing from the base, that's about how far you would have to go. So that's L. And again, let's say it has radius R. Radius R. Okay, what happens? Area of the base, again, we can specifically say it's pi r squared. And now here it gets a little bit confusing, but if you were to unwrap this thing, you would get a triangle for the lateral face. Might be kind of surprising. So you would end up with 1/2 times the circumference. So I'll write this out, 1/2 times the circumference, which is 2 pi r times L. The 1/2 and the 2 cancels, and you're left with pi RL. So finally, you just add those together, and this is being really glitchy for some reason. Pi r squared plus pi RL. And we can do the same thing we did above where we factor out pi r, just this time no 2, r plus L. So the formulas for pyramid looks like basically half of it what it was for prisms, and the same thing for cones and cylinders. You basically just divide it by 2 to get from one to the other. Or if you want to go from cones to cylinder, you would multiply by 2. So that's really nice, kind of helps keep those things straight. And it makes sense because pyramids are in some sense smaller, right? And now a sphere, there's no real context for these. So the best you can say, sphere doesn't have a base, so base area doesn't make sense. And the area, it turns out, surface area is pi r squared, which, oops, no it's not. Yeah, it is. That's surface area. I was thinking volume for a second. 4 pi r squared. For sphere, that's the best we can do. I really can't give you a reasoning as to why that should be without using like calculus or something gross like that. But it turns out that's the case. 4 pi r squared. This, if you see it when we're talking about it on Wednesday, it means I forgot to take it out of the notes. This is for the volume, not for surface area. Okay, so I'm going to do, say, 2 of these, and then we'll talk about the rest in class. I will give the idea on how to do this one, but I won't spoil everything. So let's start with the rectangle first. So I could just, if I wanted, calculate the area of every face on its own. So you would have 4 times 3 plus another 4 times 3, and then go across that way. But keeping in line with what we've done, let's calculate the perimeter instead. If you want to do it the other way, that's completely fine, but I'm going to find the perimeter. There's also something really special about rectangular prisms that hopefully I really emphasized in the volume section, is it doesn't matter what you take the base of a rectangular prism to be because every face is a rectangle. You can't do that for any other prism, even if it's like a parallelogram prism, but rectangular prisms are special in that way. So we want to find surface area, so let's go to the formula. It's 2b plus ph. 2b plus p times h. I'm going to take this bottom one to be the base. this bottom face to be the base. So that's a 4 by 12. So B is equal to 4 times 12. P is 2 times 12 plus 2 times 4 equals 24 plus 8 is 32. H equals 3. So SA, surface area, this is 48 by the way, is 2 times 48 plus 32 times 3. This should be 96 plus 96 is 192. And because it's surface area, it's in centimeters squared. I didn't say that yet, but surface area is always units squared because you're adding areas together. Spheres are as nice as they come. The trickiest thing I could give you on a pure sphere is the diameter instead of the radius, but that's not even here. So R is 13 inches. That means surface area, which is always 4 pi r squared, is equal to 4 pi times 13 squared. 4, I'm going to put the pi at the end, 169 pi. If I do that, that's 676 pi. 676 pi. So if it asked me to leave it in terms of pi, I would leave it like that. If I wanted to add a 3.14 and use that to estimate, I could do that. Either one would be fine. Just depends on instructions. Alright, so I'm not going to go through all of this, but it's a pyramid. So SA equals base plus 1/2 P times L. So this question asks you to do two things. It's kind of nefarious. First, you have to find L. That's going to require the Pythagorean theorem. And then secondly, it's going to ask you to find the area of this regular pentagon. Alright, I'm just going to pretend like I drew one. Okay. So the trick for ones like these is turn the pentagon into 5 triangles. Again, in theory, all these triangles should be the same, but I messed that up a little bit. All these triangles should have the exact same area, but now you have all the tools to figure out the length or the area of each one. And then from there you can multiply it by the number of triangles there are. So calculate L using Pythagorean theorem, calculating B by cutting the base up into triangles. This one, there's no great way to do it other than calculate the area of the base, calculate the perimeter, multiply by the height. If you want to find the area of each base, you can, but it's significantly more tedious. For a cone, you would just use the formula. And now I'm going to quickly talk about what happens in a problem like this. So what goes on here is essentially the base of the circle, the base of the, sorry, not circle, the base of the cone, that was hard, the base of the cone and the top base of that cylinder are kind of going to cancel each other out because now it's not exposed to the air anymore, right? If I were wrapping a present that was shaped like a cone and a cylinder, I would need to cover the circle on the cylinder, and I would need to cover the circle on the cone if they were apart. But if I put the cone on top, now all of a sudden I don't have to cover that with wrapping paper anymore. So that kind of disappears. But one thing that can be confusing is you still need to find the area of that bottom base there. But then after that, it's the area of the bottom base, and then the lateral surface area of the cylinder, and the lateral surface area of the cone. So don't get confused by that, because it's possible. Okay. Here's another thing that students can really struggle with. If you cut something in half, again, I like to think of like if you're frosting a cake, icing a cake. If you want to make sure that there's no actual cake showing, it's all frosting. If you frosted a whole cylinder and then you cut it in half, now this would be exposed, right? So it's going to be half of the normal surface area to get everything around it, but then you have to add in that rectangular part. So just be careful on stuff like that. Just cutting the surface area, and when you cut something in half, you might not necessarily be cutting the surface area in half. In fact, you usually have a little bit more than half because of something you opened up. This one is like the other one. This one is like the cutting in half. Here's some more cutting in half. This is a fun problem that we'll talk about in class that's good for visualizing. We haven't talked about nets too much, so that's an example. And it walks you through how to do it. Word problems, this is another one I'm going to want you to go through to help try to develop some intuition, try to figure out what's important, because this really is important for helping teach younger learners, is what do we actually use these for? What might be some considerations? Again, when we could talk about. So let's do one like this. So here we have a triangular prism. I could draw it. It has a height of 10 centimeters. Because it's a prism, I don't need to know slant height or anything like that. So I say, okay, P is equal to 5 plus 6 plus 7 is 18 centimeters. I think in the other problem I did, I forgot to write units at the end. Here's the tangent. Did I? I did. Inches squared. I had to fix that. That was a catastrophe, a sin. But it's fixed now. Okay, back to this problem. Perimeter is 5 plus 6 plus 7 is 18. It's a triangular prism, and I just realized I'm going to have to fix this later. So let me add in area of the base. Let me just make up a number. Is, say, 16 centimeters squared. Centimeters squared. So then surface area, it's a prism, so it's 2b plus ph equals 2 times 16 plus 18 times 10, because that's where the height is, equals 10. So that's 32 plus 180, 216 centimeters squared. So that's how to do it in words. I could ask you something backwards. I don't know if I did here. And then here's kind of a tricky one, but I don't think it's too bad. Again, you would want to draw it. You wouldn't see this circular part here. I can draw this a little better. So to just draw the cone would look like this. And this would actually meet up. And then you would have the ice cream on top, and you would figure out surface area altogether and kind of divide through when you finished.